Hi depths! In this chapter, I introduce embeddings as the mechanism that allows semantic search. The goal is to explain the idea without going too deep into mathematics. Students only need to understand that we convert text into numeric vectors and then compare those vectors to find meaning, not exact words. I start with a simple definition. An embedding is a vector, a list of numbers that represents the approximate meaning of a text. The example helps students understand the value. DDD architecture and domain-driven design may use different words, but semantically they are related. In vector space, they should be close to each other. This is the foundation of semantic search. This slide compares traditional search with semantic search. A SQL-like or exact text search works well when the same words appear in the document, but it can fail when the CV uses related vocabulary. Embeddings help us search by meaning. This is why a question about backend experience may still retrieve sections about REST APIs, .NET services, or architecture work. Now I connect embeddings to the project. Each resume chunk is sent to the embedding model, for example, through Ollama. The model returns a vector. We store that vector in PostgreSQL using pgvector. Later, when the user asks a question, we generate another vector for the question and compare it with the stored vectors. The database returns the top key chunks that are most similar to the question. This is a very practical slide. Chunk size has a direct effect on answers quality. If chunks are too large, they contain too many different topics, and retrieval becomes noisy. If chunks are too small, they may lose important context. A balanced chunk keeps related paragraphs together, while still being focused enough for a semantic search. Here, I explain the data model at a high level. PostgreSQL stores the document metadata, the extracted chunks, and the embeddings vector for each chunk. The chunk has text and order, so we can preserve the structure of the origin CV. The embedding is what allows pgvector to calculate similarity. This slide prepares the student for database tables and entity framework core entities later in the implementation. To summarize, embeddings are the bridge between text and semantic search. They represent the meaning of text as numbers, which allows us to find relevant information, even when the user and the resume use different words. Finally, I repeat that chunk size matters because retrieval quality strongly depends on how we split the document. Thanks for watching. In this demo, we built a CV chatbot powered by generative AI using ASP.NET Core Web API, Ollama, RAG, PostgreSQL with pgvector and clean architecture. See you depths! Have a nice day!